Welcome to Chemistry Lab. Today's topic, safety and measurement. You like the lab goggles? Yeah, you're going to wear them all the time that you are in the wet chemistry lab. They're a tad uncomfortable. They leave these lines under your eyes, fashionable lines. But you know what? We don't care. You have to wear these goggles all times that you are in the chemistry lab. They protect your eyes, and they are required by law to wear when you are in the wet chemistry lab spaces. Also, you are required to be completely covered from the waist down, no shorts in lab, and you have to wear shoes to cover your feet. No sandals are allowed in lab either. I'm wearing a lab coat, which is not required. I'm wearing it for fun, but you should wear something to cover your shoulders when you're in lab, and I recommend an old t-shirt. We have electronic balances in the lab to measure mass. You push the 0 button to get a reading of 0, and then place the item you want to measure on the balance, and make sure to record all of the places past the decimal in your data. If you want to measure the mass of a liquid, then what you can do is push the 0 button again with the beaker in place, remove the beaker, pour the water into the beaker, and place it back on the balance, and now you have the mass of the water in the beaker. You should never pour liquids into a beaker while it's on a balance. Another way to do this would be to measure the mass of an empty beaker, then the mass of a full beaker, and just subtract to get the mass of the water. At some point in the lab, you're going to be asked to measure water out of a burette. This is a burette. It's kind of an odd piece of glassware in that the very top of it here is marked with 0 milliliters, and 50 milliliters is marked somewhere down close to the bottom. It has water in it now, and in order to dispense 10 milliliters from this, you just need to look at the difference in water level and get it as close to exactly 10 milliliters as you can. You can technically read a burette to 2 places past the decimal. So if the water level here at the bottom of the meniscus, which is that little dip that water makes, if you read the bottom of the meniscus at 0.50 milliliters to start with, then you just dispense water until the reading is 10.50 milliliters, and that should give you the 10 milliliters of water that you desire. Next topic, unit conversions. I know you're spending a lot of time in class on unit conversions, so I don't want to go all the way through that. But in lab, you're going to be doing some work with cubed unit conversions, so I do want to spend a little bit of time looking at that. Cubed units of length are units of volume. If you consider a cube that measures 1 decimeter by 1 decimeter by 1 decimeter, length times width times height, that is a cubic decimeter. And that corresponds to what we call a liter. Right? A unit of volume is just a unit of length cubed. If you break this down into centimeters, and I'll approximate that here, there are 10 centimeters equal to 1 decimeter. And if we pull out 1 cubic centimeter, that volume is equivalent to what we call 1 milliliter. Now, you have memorized that there are 10 decimeters in 1 meter, and you have memorized that there are 100 centimeters in 1 meter. And as we pointed out, that means 10 centimeter to 1 decimeter. If we take the linear relationship, 10 centimeters equal to 1 decimeter, and cube that relationship, just cube everything, 10 cubed centimeters cubed equal to 1 cubed decimeter cubed. Of course, that is 1,000 cubic centimeters equal to 1 cubic decimeter. And if a decimeter cubed is the same as a same as a liter, and a centimeter cubed is the same as a milliliter,
we have 1,000 milliliters equal to 1 liter. In other words, if you know the linear relationship, then the cubic relationship is just everything cubed. Now in lab, you will be doing some calculations with these cubed units. In one of the pre-lab questions, you know the volume of a lake in cubic kilometers. I'm not sure what that number is, so I'll write it this way, in cubic kilometers. And your goal is to convert cubic kilometers to liters. We know that liters are the same as a cubic decimeter. So we're going to take cubic kilometers, and using what you memorize about linear units, we'll have the cubic relationship. You have memorized that there are 1,000 meters in 1 kilometer. And the cubic relationship will be 1,000 cubed meters cubed over a cubic kilometer. And we've set it up so that the cubic kilometers cancel. This gives us meters cubed. You've also memorized that there are 10 decimeters in 1 meter. We'll set it up so that the units cancel. 10 decimeters over 1 meter. So the cubic relationship is 10 cubed decimeters cubed over 1 cubic meter. We have our answer in cubic decimeters, which is the same as liters. Don't forget to complete the pre-lab questions and have a great lab.